Hey guys, we're gonna go ahead and get started now. So, how did you guys feel about week 6 functions? The sections, the challenge activities, and the labs. Pretty good. Well, that's good because this week is gonna be all about functions as well. This is actually going to be a continuation of functions because there's so much to learn about it. So I hope everything you learned from week 6 is solid. Valerie Morris says, so from now on, does the labs want us to define the function? If a lab tells you that you should do something in the form of a function, you should. But yes. Anyways, so I kind of skimmed through week 7 material, and I was actually pleasantly surprised. There was a couple of things about functions, because I've been coding in C++ for 5 years. There was a couple of things about functions that I did not know previously, so this was a pleasant surprise. It's a learning experience for me as well as this for you. So today we are going to do what we've been doing before. We are going to do as many sections as we can in this time frame, and whatever we don't do, it's your responsibility to do by yourselves on the weekend. So starting with 7.1, it's 7.1 says default parameter values. Now, it says sometimes a function's last parameter or last few should be optional. A function call could then omit the last argument, and instead the program would use a default value for that parameter. A function can have a default parameter value for the last parameter or parameters, okay? Meaning a call can optionally omit a corresponding argument. Now, as you already know, when section refers to arguments, it's referring to the variables that you can pass to a function, right? So take, for example, this example here on figure 7.1.1, parameter with a default value. So as you may know, here in America, we list our dates by month, day, year. But in Europe, they actually list their dates as day, month, year. Okay, so this is a function that accepts 4 parameters or 4 arguments. Okay, they're all of type int. The first one is going to be the day. Second one is going to be the month. Third one is going to be the year, and the fourth one is going to be the style. Okay. Now, style can hold 2 values. We can set style to 0 if we want to output the American style. But if we want to output the European style, we should put it to 1. If you can look at the difference here, there's an if statement here. When print style is 0, it'll output month, then day, then year. But when it's 1, it'll put day, then month, then year. Do you see that? So if you look at the int main, the int main calls the date print function 3 times. See? So in the first 2 times it's called, it says 37/2012 0. That tells the function that we want to output this using the American style, right? And that's the reason why you see 7/30/2012 separated with slashes, right? In the second call, it says 37/2012, but this time the style is 1. This indicates to the function that we want to output it in the European style, right? So because print style ended up not being 0, this evaluated to be false, and it looked at this else if. Because it was equal to 1, it did this instead and said day, month, year. And this is the second output, see? Now, the third call is a little bit interesting. Notice that it only has 3 arguments instead of 4. See that? What happens as a result is that when it's called, because an argument was not passed on to style, the default variable was that it was equal to 0. And the reason why it's equal to 0 is because if you look closely at the function definition here, well, the very first line of the function definition, you see int current day, int current month, int current year. But over here for int print style equals 0, do you see that equals 0 there? This basically says if print style doesn't get an argument for it, the function will automatically default it to 0. Does that make sense? So in the third function call, even though we only have 3 parameters, the function is perfectly okay with that because print style says, if I don't get an argument, I'll just set myself equal to 0. Does that make sense? Now, can anyone guess what would happen if we didn't have this equals 0 here and then we ran this line of code? It's not hard to guess. It would crash because an argument is not initialized, right? So moving on. The fourth and last parameter has a default value int style. Yeah, I already said this. If a function does not provide a fourth argument, then the style parameter is 0. The same can be done for the other parameters. So if you really wanted to, you could write your functions like this and have these be default parameters, right? So instead of saying int current day, you could say int current day equals 1, and that's the default. Current month will be 1, that's the default. Current year would be 2000, that's the default. And if you did do that, all of these function calls would be valid, right? So when we do a function call with all 4 parameters, that means no defaults are called. The function will just work as is. But when we do one with just 3 arguments, style will be set to 0 because that's the default. If we did this, style will be set to 0 and year will be 2000. So 2 defaults are used. In this one, since only 1 argument is put, it needs 3 defaults. And I like this comment here. This is strange but valid. And then if you call the function with no parameters, it'll call all the defaults. Okay. Any questions? No? Okay. So, what's this? Okay. So, when you compile your own programs, if it says that there's too few arguments in the function call, that means that you either call the function with not enough arguments or you didn't set any defaults. So keep that in mind when you're coding on your own. But we're ready to do this participation activity now. So given a function of type void, which means that it doesn't return anything, called calc stat, we have num1, num2, num3 has a default, which is 0, and user method is a car, which also has a default, which is a. A compiler error will occur because only an int parameter can have a default value. True or false? Say in the chat what you think the correct answer is. How many of you think it'll be true or false? Everyone seems to say false, but yeah, it's false. Yeah, any parameter type can have an assigned default value, right? Now, Let's do the next question. The call calcstat 44, 47, 42b uses user method A because the parameter default value of A overrides the argument B. True or false? Again, this is false. So when it says, so the way defaults work is that it'll assign it to the default if no other value isn't put into it. But in this case, a value is put into it, it's B. So the claim that A overrides the argument B, that's not true. The opposite's true. The B overrides the A. Now, what about this one? The call calcstat 44, 47, 42 uses user method A. What about this? True or false? Yeah, it would be true because since our user method wasn't specified, user method defaulted to A. Okay. And then what about this one? The call calcstat 44, 47b uses num3 equals 0. True or false? How do you feel about this? Now, see, this question is trying to trip you up. Would num3 default to 0? Oh. I would say that it would, right? Oh, no. Call has 3 arguments correspond to. I see. Okay, so this would actually be false, right? Because when you put B as the third argument, you think that the function's smart enough to take the B as the user method, right? But it's not, because it's a third argument. It'll take this B and pass it to num3, and because B isn't is not an int value, the compiler will convert B into its ASCII number. So the order in which you put your parameters is important. So that's why it's false. And now consider the last question. The following is a valid start of the function definition. Void my function. Int num equals 1. Int num1 equals 0. Int num2 equals 0. Car user method. How do you feel about this? How many of you think this is a valid start? I would argue that it isn't, because the first two variables have defaults, but the last one does not. And defaults have to move from the last parameter backwards. So you can't have defaults for the first two arguments, for the first arguments, but not have default for the last arguments, right? So I would say this is false. Yep. And the explanation is said here. Okay. Okay. All right. So now we're ready to move on to this challenge activity. So let's take a good look at this and try to understand what's happening. So we have a function called show, which takes 3 ints as arguments called A, B, and C respectively, but C has a default of 17, right? It'll see out A, put a comma in a space, see out B, put a comma in a space, and see out C. So when we call show with just 2 arguments, 5 will be passed to A while 6 is passed to B. Because C doesn't have a value, it'll default to 17, and that's why we see 5, 6, 17 in the first in the terminal, right? But when we do the same call with the third parameter, 7, the 7 will override the default and it'll output 1, 8, and 7. Let's start. So type the program's output. Because we're showing 2, 6, and 4, I would say that the output would be 2, comma, space, 6, comma, space, 4. Oh, it wants me to show everything. Let me do that again. Three, comma, 4, 6, 7. Oh. I didn't realize it changed it. Let me do that again. I have to put a space at the end. My bad. There we go. And then what about this one? In this function, show has all 3 of them being defaults. So what would the output be for this situation? So in the first show, A would be 9, B would be 8, C would be the default of 3. So 9, 8, and 3. And the second call, A would be equal to 2, but the B and C would be their defaults of 7 and 3. So we would say 2, 7, and 3. And then lastly, because this call of show has no parameters, all 3 defaults would be used. So we would output 5, 7, and 3. 5, 7. Try it. Yep. So last, we have this challenge activity. Okay. So so let's put our brains together and try to figure out the way we should do this. So write a function number of pennies that returns the total number of pennies given the number of dollars and optionally a number of pennies. So the word optionally here means pennies should have a default value. The default value in this case being, well, if you don't have pennies at all, the default value would be 0, right? So let's work on this together and try to figure out what the function will be. Now, before any sort of in the function definition, the very first thing I need to say is the type. I think we need to establish num of pennies and num of dollars as ints. Yeah, we're going to do exactly that, but we're not going to do it in the int main, of course. We're going to do it in the function definition, right, Valerie Mora? So here's what we're going to do. Now, because every function needs a data type, right? The data type is the same as the thing that it's returning. Like if a function returns a string, it should be, the function type should be string. If the function returns an int, the function type should be int. However, if a function doesn't return a type of value, and it just does some kind of process called couts, for instance, we'll put void in its place. So what about number of pennies? Are we returning anything? What do you guys think? Slayman Toki says yes. What exactly does void do? So the void keyword is used in place of the data type for a user-defined function if it doesn't return anything. If you'd like me to, we can talk about it after we do this, right? But okay. So I say that number of pennies. This function doesn't return any sort of data. It just couts some values. So if that's the case, number of pennies would be a void function. That's what I say. Okay. And then next, I will say the I'm sorry, Slim and Toki. Can you clarify your question? Like, oh, you're saying that I should make the default for num pennies equal to 0? Yeah, that's what I'm gonna do. Yeah, but the very next thing I gotta say is the function name. Here it's gonna be number of pennies, right? Okay. Now inside the parentheses, I need to have my arguments, right? Now this function can take 2 arguments, right? One is going to be number of pennies and the other one's going to be number of dollars. So we're going to do what Valerie Mora suggests in the chat and say num of pennies and num of dollars. So we're going to say int num of pennies, and then actually dollars should be first, right? Yeah, I think dollars should be first. Int num of pennies. Now, the reason why I had to say dollars first instead of pennies is because pennies can be a default, but dollars cannot. So arguments that have defaults should be the last arguments that go into the function, right? So this time, at this point in time, we're gonna do what Slayman Toki says in the chat and set the default for num of pennies equal to 0. Okay, so equals 0. There we go. So this is good so far. We're actually nearly complete. Now we just need to write the function definition. So how do we compute the number that's we need to output given these parameters? Well, if dollars is 6 and pennies is, if dollars is 5 and pennies is 6, it should print 506. And if dollars is 4 and no argument is put for pennies, they'll just output for 400. Okay. So yeah, we're gonna do what Slayman Toki suggests in the chat and multiply the number of dollars by 100. Right. So we're gonna out num of dollars times 100, and then what? I'm gonna say plus, yeah, and then add the pennies, right? Num of pennies, like that. And that should be it. Let's run it and see if it works. Failed to compile.
Oh, the void part of the function just counts like the void function is already printing out the variables, so you don't actually need to cout in the main function.
I'm sorry. What exactly are you? So what do you think I should change?
Okay. Does the question say what we need? What kind of function that the number of pennies needs to be?
Does the function say The value.
Like, does the question say what kind of? Oh, we could just make the number of pennies an int then. Yeah.
It's already an int.
No, the function itself. It's a void.
Yeah. You're saying change it to an int, right?
Yeah. And then you could just return the number of dollars times the right, because we're already
Oh
outputting.
yeah, you're right. I didn't see this.
Yeah.
My bad. So my bad. This is supposed to be a because we're
Yes.
outing it, we're treating this like a variable. So it's an int
Yeah.
variable. My bad. So instead of saying C outs,
You just return it.
I should say return. My bad. Thank you for catching that. Yeah, like, well, I thought it was going to be a void function, but apparently this is an int function because we're treating it like a variable. Thank you for catching that. Like, hey, it looks like a lot of you in the chat caught that too. So kudos to you guys. You guys are really sharp. So let's try this again. All right, perfect. It works. So now we understand how default variables work, right? All right. This is good. Let's move on. So 7.2 looks well interesting. 7.2 says functions with string and vector parameters. So functions commonly modify a string or vector. The following function modifies a string by replacing spaces with hyphens. So let's look at this example here and try to figure out what's happening here, okay? So in this example, this is a function that replaces spaces and hyphens, and it's a void function, right? That means it doesn't return anything. It just modifies the variables that's passed to it, right? So stir space to hyphen. It takes a vector of string called mod stir, right? And we have the dereferencing operator here, okay? Now, how many of you don't know what the dereferencing operator does? Do I need to take a moment to explain that?
Yeah, could you explain, please?
Oh, so my question to everyone is, how many of you don't know what's the purpose of having this ampersand here in front of the data type? You don't know it? Okay. So at this point in time, you haven't learned pointers yet, have you? Uh, uh, that's a good question, Valerie Moore. Valerie Moore says in the chat, does it combine like union? And the answer is no. It actually has its own special purpose.
It's a reference parameter, right?
Yeah. I'm gonna try my best to explain it to you, but it's gonna be. I'm not sure how much my explanation will make sense since we didn't learn pointers yet. But you see, something that you need to know about user-defined functions is that when you pass variables to it, when you pass arguments to user-defined function, the function itself, because it's a completely separate function from the int main, and variables in the int main are inside the scope of the int main and outside the scope of all the other functions. When you call a function, it doesn't actually take the variable that you pass to it. It makes a copy of it and then calls the copy whatever it calls it in the definition. So see in this int main, it says it's calling the int main calls the function string space to hyphen user string, and user string is a string that belongs to int main. It doesn't take the variable itself. It makes a copy of the variable and calls it something else. So if we, what ends up happening is if we didn't have this ampersand here, we would be editing the copy called mod stir, and user stir would be unchanged because we're not changing user stir at all. We're changing the copy that the function made. By putting this ampersand here, this is the dereferencing operator. By doing this, we're not asking the function to make a copy and then of the variable and then just do its thing on that. We are sending the address of the variable that's assigned to it in memory and passing that instead. And by doing that, we can edit the a variable that belongs to the scope of this variable. Like I could take a brief moment to show you in Visual Studio. Do you guys want to do that? Yeah, like it's a little, it's kind of hard to, I would think from your perspective, it's kind of hard to understand since you didn't learn pointers yet. Right? So I'm going to call this example DOF. So let me put this over. Let's say so. So I'm going to make a very easy function here. So this function is going to be a type int, and I'm going to call it, I'm going to think of something simple. And I'm gonna make a function called mul10, which will take an int value and return its value multiplied by 10. So I'm gonna say return a times 10. And I'm gonna say int and int equals maybe 7. And then I'll say mul10. Right. And I'm gonna say cout before multiplying by 10. And then after multiplying by 10. So So I want you to see yeah. So I want you to see what's happening here.
Yeah, at line 14, shouldn't it just be cout and int instead of the function?
On line 14.
Yeah. Like, do you want to call the function at line 14?
Oh, my bad. You're right. You're right. I don't want to call the function there. So we know that my int and integer is going to be equal to 7, right? So before multiplying by 10, it's going to be 7. What do we think will happen after I do this mul10 multiply by 10 function? So if I ran this, oh, actually, I don't want to see out this at all. I just want to, I'm going to, so let's try to understand what's happening here. So when I multiplied this by, let me do this. So I have an integer called an int, which is equal to 7. And I see out it right now, and it's 7, right? I do this multiply by 10 function. And when I see out an int again, you can see that it's still 7. So you can see that this function didn't work, right? The reason why it didn't work is because this is going back to the thing that I said earlier. Like you can even see it much better if I decide to debug it instead. So let me debug this. Put the terminal here. So this is declared in memory. You can see here, and int is 7 right now. And then I do the multiply by 10. So the compiler will jump to the function definition, right? So 7 is passed as a, right? Now you can see that an int is in the scope of the int main function. So the mul10 function doesn't know what it is. It didn't actually take the an int variable. It created a copy of an int variable and called it a. As you can see in the auto section, a is equal to 7. See that? Notice that it did not say an int equals 7. That's what happens. So what happens as a result is that I take 7 and multiply it by 10. And then when I leave the function, the copy that I multiplied by 10 disappears. And by changing the copy, I actually didn't change an int at all, right? And that's why it's still 7. So what I need to do is actually dereference the variable that I'm passing to it. And the way you do that is by putting the dereferencing operator, which is the ampersand here. Right. So by putting this here, I'm not making a copy of the variable at all. I'm actually sending the address of where an int is in memory and sending that instead. So if I ran it again, because I'm changing a directly, this should result in 70 if I ran it again. It's not. Wait. Wait a second. It's not. Hmm. All right, let's see what the chat's saying. What if you replace and online 18 to me? Well, actually, I did a whole video lesson on dereferencing operators before, but right now, I think I need to look at that video again to figure out why this isn't working. But yeah, it's not working. I'll show. Actually, I'll figure this out and show you guys another time. I think I spent too much time with this already. But basically, try int ampersand a. No, I don't think that'll change it. Because I don't think it matters where you put the dereferencing operator. Nah, it didn't change it. I'm sorry. I'm gonna have to brush up on my C++. I'm sorry, guys. But moving on. Yeah. So but you know, dereferencing is not the main topic here. It's functions. The string serves as a function input and output. The string parameter must pass by reference, achieved by using ampersand, so that the function modifies the original string argument and not a copy. This is what I was trying to say here. So modifying a string parameter, space to hyphens, run the program noting correct output. Remove the ampersand and run again, noting the string is not modified because the string is passed by value and thus the function modifies a copy. When done, replace the ampersand. Okay, so this is doing what I was trying to explain before, right?
Wait, was your function a void or an int?
Int.
This one's a void. Do you think that's it?
Could be. Let's try again. Yeah, C++ is a finicky void.
Oh, because of yeah, because a void doesn't return anything, does it?
Yeah. I have to look at my old video and dereferencing to figure out what I'm doing wrong. But don't worry, I'll say it in the when I figure it out, I'll let you know later. But yeah, so so you understand that functions make copies of variables and not actually work on the actual variables, right? So let's do what it says here and remove the ampersand and run it. Do you notice that the spaces were not replaced with hyphens? That's because we didn't modify user string at all. We modified.
In the function, do you have to actually like physically reassign the variable?
Physically reassign the variable.
Like actually like reassign it to the because that's what we're doing here, right?
Yeah.
I think that's what your function was missing.
Oh. So
Is
you're
so
saying
like a equals?
a times 10.
Not in that point. Where you have down there.
Well, now it's doing it.
There you go.
Oh, all right then, cool.
Yeah. So if I didn't have the ampersand here, what I'm doing is that I'm not multiplying an int by 7. I'm multiplying a by 7. A is the name of the copy. So by putting the ampersand here, I'm changing an int directly because I'm not sending an int. I'm sending the memory address of where an int is in memory. That's what I was doing wrong. I was missing the a equals. That's why. That's what I was trying to show you guys. But hey, thank you for your help. You are all very, very smart. And yeah, it warms my heart to see that you guys are really into this. But yeah, so basically I showed it here. Zybux showed it too. Yeah, functions don't take the arguments, they take copies of the arguments, and that's why. Now modify the function. Oh, and let's do what 3 says. Modify the function to also replace each exclamation point with a question mark. So so it says modify the function so that whenever it sees an exclamation point, we'll replace it with a question mark. So I guess inside of this inside of this for, after this if statement that changes spaces to hyphens, I'm going to make another if statement that changes exclamation points to question marks. So if mod stir dot at I equals, it's a character, so I need to use single quotes instead of double quotes. If it equals exclamation points, I will change it to, instead of exclamation point, it should be question mark. Let's go ahead and put the ampersand back. Okay. Okay, so you can see that by adding these few lines, I made it so that whenever we see an exclamation point, you replace it with a question mark. But if I didn't have the dereferencing operator here, it did not change because I'm not changing user stir, I'm changing the copy called modster. But yeah. So this is what passing by reference is. If you pass by reference, you're gonna need to use the dereferencing operator, which is the ampersand. Okay. All right, what now? I think we have time to look over this program here, and then we can call it because we're kind of at time. So sometimes a programmer defines a vector or a string parameter as pass by reference, even though the function does not modify the parameter, to prevent the performance and memory overhead of copying the argument that would otherwise occur. So that's very important here. When the function makes a copy of an argument that you're passing to it, the copy takes just as much space in memory as the original does. So now you're not worried about this if you're passing small values like ints or strings or chars, but imagine you were passing to a user-defined function a vector of ints or a vector of strings. For all we know, that vector could have 100 or even 1,000 values. And because you're passing it to a function, you're making a copy of it and it's consuming more memory than necessary. And you don't want to do that, right? You're going to learn this when you take upper division classes. The programs you write need to, not only do they need to work, getting them to work is one thing, but they also need to be efficient too. And if you're needlessly wasting memory to hold copies, that's not very good. So if we pass vectors, oftentimes we will pass by reference. That way we're not making a copy and it's not wasting space and memory. Does that make sense? Okay, so the keyword const can be prepended to a function's vector or string parameter to prevent the function from modifying the parameter. So if you are passing a variable by reference, there is the danger that your function could accidentally modify the value that's being passed to it. You can circumvent that by having the const keyword on top of it. That way, it will prevent any variables that you pass by reference from being changed. Okay. Now, the following illustrates the first function modifies the vector defines a normal pass by reference. The second function does not modify the vector, but for efficiency uses constant pass by reference. So looks like, so this is being passed by reference. This is also being passed by reference, but we have the const keyword in front of it. Okay. So if we ask the user to enter 8 values being 10, 20, 30, 40, 50, 60, 70, we'll reverse the values. In other words, from beginning to end, we will, whatever's the last index will become the first index, and then so on and so forth. And then when we print the values, we can see it. So in this yellow highlight, we passed by reference, but we didn't have a const. This time we passed by reference again, but we did have a const, right? Now, as you already know, the reason why we pass by reference is because we don't want to change the copy. We want to change the variable itself. In this case, the variable being the vector of int called user values, which belongs to the scope of the int main. So we pass by reference to prevent needlessly wasting memory. So by passing by reference, the function doesn't make a copy. It just works on the variable directly. And that's why we have the ampersand here. Now, notice that we don't have the const variable here. The const variable prevents us from altering the argument that we're passing to it. In this case, we are altering it. We're reversing the number of the order of the integer values, right? Now, in this case, when we say print vals, we have a for loop that iterates to the whole vector and just counts everything. Now, because we're just reading the data and we're not modifying it at all, this is the situation where you want to include the const keyword because you don't want this function to accidentally alter the variables that you're passing to it. So that's very important to keep in mind. Like from this point on, when you're making functions and you're passing small values, you can just pass them directly. But if you're using large values like vectors, it's a good idea to pass by reference by having this here. And if you are passing by reference and the function itself is not altering the data that you're being passed to it, it's a good idea to put the const keyword in front of it. So know when to use this and know when to use this. That's the takeaway from this particular section. This is a very, this is a very well-written section. I kind of like this. It explained it much better than I could. So, we are at time here. Unfortunately, I can't do these, but this section is very self-explanatory. I think you guys can do it on your own. And if you can't do it on your own, remember, you can always email me and ask your questions there. I hope you're doing the challenge activities on top of doing the sections, because those are worth points, right? Now, does anyone have any questions before I wrap up this meeting? Did anyone ask any questions in the chat? Let me quickly check. You're all good? Okay, great. So yeah, so I suppose that's it for now. Please do this section on your own time. I also do the rest of the sections on your own time during the weekend too, because it's all worth points. So if that's it, I think we can wrap up this meeting now. Okay. So yeah. Thanks everyone for coming. You all know what you got to do. Just do the sections, and then we will, on our next meeting next Tuesday, we will start looking at the week 7 labs. So good night, everyone. Have a good weekend.